The population growth equation is virtually identical to the continuous compounding equation. So notice, remember the continuous compounding equation is A equals PE to the RT power, with E being our special number, 2.71828182845.9, et cetera, et cetera, et cetera. The population growth also uses E, but notice that instead of saying principal or initial amount in the continuous compounding formula, we deal with A being the initial population. Capital A is still the ending amount, but they use a Y instead. R is the interest rate, but K is referred to as the rate of continuous growth, but it's still going to be a percentage that you change to a decimal. And T still represents time. So let's do a problem that deals with continuous exponential growth in a population. In 2015, the population of the state of Georgia was 10.2 million people. In 2010, it was determined to be 9.7 million people. Determine the value of K, Georgia's relative rate of growth. So we're going to use our formula. It's not a new formula because it's done virtually the same way as the PERT formula, PE to the RT power, but it's A, E to the KT power. So we know that in 2015, the state of Georgia's population was 10.2 billion people, and in 2010 it was 9.7. So 10.2 will be the ending population we'll put in for Y, and 9.7 is going to be the starting population that we place in for A. We're trying to solve for K. We do know the value of T, though, because we're dealing with a difference of 5 years. We're dealing from between 2015 and 2010, so time is going to be 5 years. So if I switch that around, it's going to be 10.2 equals 9.7 to the 5K power. That's 9.7 there, if you can read that. Okay, we're going to divide both sides by 9.7. Forgot my E up here. There we go. So 10.2 divided by 9.7 is approximately equal to 1.0515. So that's E to the 5K power. And then remember, we can, since we're trying to solve for K, which is in the exponent, we should use a logarithm. And the logarithm we're going to use is going to be a natural log, because natural logs work well with E. So we'll take the natural log of both sides, and that will give me whatever the natural log of 1.0515 is, equal to, and the L and the E cancel each other out, just 5K. So to finish solving this, I'm going to divide both sides by 5. And that will give me K equal to whatever the ln of 1.0515 divided by 5 is. And you get approximately equal to 0.0100 if I round it to 4 decimal places. And so the population growth, if I change that to a percent, would be about 1% after moving my decimal 2 to the right. So we're going to use that information for K to answer questions B and C. It said, when will Georgia's population reach 12 million people? So we'll go back to our formula, Y equals AE to the KT power. We're trying to figure out when Georgia's population reaches 12 million people, so that will be the ending amount, so 12 million, or 12 to represent 12 million, equals, the starting amount is still 9.7, E, but we have figured out what K is. K was 0.0100, which I don't need those extra zeros at the end, so I'll just use 0.01 to the T power. And we're actually solving for T. And we're going to solve this very similarly to the first part of Part A. Get E by itself by dividing both sides by 9.7. So 12 divided by 9.7 is approximately equal to 1.2371. So that'll be equal to e to the 0.01 t power. And then just like the last problem, we will do a natural log of both sides. And natural log of e, that will cancel that out, leaving us with just 0.01 t equals whatever the natural log of 1.2371 is. So we'll divide that by 0.01. And when we take the natural log of 1.02371 divided by 0.01, we get t is approximately equal to 21.277. So the question asked, when is Georgia's population going to be 12 million people? So we're going to have to add 21.277 years to the starting amount, or the starting year. So if we look back up here, the starting year was 2010. So 21 years after 2010 would be about sometime early in the year of 2031. And then part C, Ohio's population in 2010 was 11.6 million and can be modeled by y equals 11.6 e to the 0.004 t power. Determine when Georgia's population will surpass Ohio's population. So again, going to have to scroll back up to remember what the formula for Georgia's population was. And the formula for Georgia's population is right here. It's the 9.7 e to the 0.01 t power. So we want to figure out when will that exceed the formula that we're using for Ohio's population. So I will take 9.7 times e to the 0.01 t power. So that represents Georgia. And it says when we want it to surpass Ohio's population, in other words, be larger. So I'm going to set that greater than the formula for Ohio's population, which you can see is 11.6 e to the 0.004 t power. Okay, so this time we have an e and a on both sides. So the best way to solve this one is actually to think about what we did a couple of sections ago, is when we do the natural log of both sides, how do we do a natural log of something when there is the natural log of two parts being multiplied together? Because we have a 9.7 being multiplied times e to the 0.01 t power, and we have a natural log of 11.6 being taken times e to the 0.004 t power. And remember that the multiplication of logs can be expanded to be represented by the addition of those logs. So we're going to do an expansion on this one. We're going to take the natural log of 9.7 and add it to the natural log of e to the 0.01 t power. So notice that it's 9.7 e as a single logarithm, but that can be expanded to two separate logarithms through addition. We're going to figure out when is that greater than the log of 11, natural log of 11.6 plus the natural log of e to the 0.004 t power. Okay, so the natural log of 9.7 is about equal to 2.2721. And we already know what the natural log of e to the 0.01 t power is because that'll cancel each other out. So that's just going to be 0.01 t. It's going to be greater than the natural log of 11.6, and that is about 2.4510 plus, so the ln of e cancels out, just 0.004 t. So finally at this point, I forgot my plus sign over here. Let me fix that. So At this point, it amounts to basically an Algebra 1 question. We need to get the t's on one side of the equation, everything else on the other side. So to get the t's on the same side, I should subtract 0.004t from both sides. And if I'm moving the t's to the left, that means I need to move everything else to the right. So I'll subtract this negative 0.22721 from both sides in the same step. So those will cancel and leave us with 0.006t is greater than, so those will cancel on that side, whatever 2.4510 minus 2.2721 is, and that is approximately 0.1789. And then divide by 0.006. We get t approximately equal to 29.816 repeating. And again, the question is going to be, when does the population of Georgia exceed that of Ohio? So we need to add 29 years to the starting year, which, if you recall, was 2010. So that's going to be sometime late in the year 2039. Maybe close to the year 2040, but likely somewhere late in the year 2039.